Okay, now we're moving on. This should be question number 10. So question number 10, we have our same aircraft, same one described up here in question 8, but it's going to have the coefficient of lift from question 9. Okay, now this aircraft that took off from Dubai on that nice, wonderful July day has now flown all the way to Hong Kong. Okay, long flight. It's gone 5,950 kilometers. It's used 82,900 liters of fuel, which is 21,900 gallons of gasoline or jet fuel. Okay. Assume an average day in July in Hong Kong is 32.8 degrees Celsius. That is different from Dubai. Okay. With a standard pressure of 101.3. Hey, same air pressure. They're kind of being a little nice to us. What is the minimum speed the aircraft can land? Assume that the same 1.24 coefficient of lift and that the jet fuel burned has a density of 0.803 kilograms per liter. We're going to need this to kind of help us figure some things out here in a minute. All right. So what we're trying to find is what is the minimum speed the aircraft can land. So we don't want to go, if we go too slow, if we go below that speed, why is this important? That plane can stall, and if that plane goes too slow and stalls, then everybody will crash and die, and we don't want to hear any more about people dying in airplane crashes. Okay, so we're going to work through and see what we can come up with. So first thing we need to do is we need to calculate our air density because we have a different temperature, we have the same pressure, so now we're going to calculate our air density in Hong Kong. So density equals pressure all over our constant of 0.2869 times our temperature, and in this case our temperature was 32.8 degrees Celsius plus 273.1, that's our constant in Kelvin. Okay. Oh, our pressure, sorry, was 101.3. Right? So we calculate that out. So hopefully you'll take your time, pause, calculate that out. You should end up with 1 point something, just like we would have come up with in question. Well, it's not going to be the same. It's going to be a little lower, I believe. I'm trying to take a look here and see. Is it going to be lower? It should be. No, actually it's higher because the temperature is going to be a little bit higher. Okay. So there we go. Okay. All right. So our air density is just slightly higher. It should be. All right. Now, this is step 1. Step 2 is we need to calculate the mass of the fuel burned. So to calculate the mass, we burned 82,900 liters of fuel, but each liter weighs 0.803 kilograms per liter. Okay, so there is that fabulous little problem right there. So this is how much fuel was burned. Remember, our plane flies. It's going to weigh different by then when we get over there, especially after a really long flight. Okay? All right. So we're going to do that. Now we need to recalculate the mass of our aircraft. So again, we're going to take our aircraft, and in question 8, our mass was, the maximum weight of the plane was 457, 452, and we're going to take 92 times 0.92%, okay? And then we're going to subtract that answer from step 2. Right there, okay? So there's our weight of our aircraft. We were at 92% when we took off, and we're going to subtract how much fuel we burned, and that will be our answer. Okay? So next, now that we've done that, we need to calculate our new weight. So step 4 is calculate the weight. So now that I'm going to take step 3 answer, and to change our mass into weight, I'm going to multiply it by 9.81 meters per second, which is what gravity is acting on, and that's going to give us our weight. Okay? So there you go. If you're following along, you can pretty much plug this in. I've walked you through. I've given you part of the answer, so you should get 1 point something if you do this correctly. Okay? If not, text me or send me a reminder or message, and we'll talk about, you'll figure out how you're not calculating, you typing in the numbers right. Okay? So then here, you're going to calculate the fuel that was burned. So we're going to take the amount of fuel, multiply it by the density of that fuel, and then we're going to subtract our weight at takeoff, and we're going to subtract our fuel that was burned, and then we're going to take that answer, multiply that by gravity, and that's going to give us our new weight of our aircraft, which should be quite a bit lower than our takeoff weight that we had. Okay? Now comes the fun part. Get ready for this. So here's our coefficient of lift formula. 2L all over area, air density, and velocity squared. So here we go. Our question is wanting us to find V. So how do we get V out of here? Well, it's on the bottom, so I have to multiply V. Okay, so if I multiply V, I'm going to end up with, so if I multiply V squared over here, then I'm going to end up, and over on this side, I have to divide CL. So if I do that, I'm going to get V squared over here, and I should get 2L over A, air density, velocity squared, and because I'm dividing my coefficient of lift, it will be down here on the bottom. So there's part of the formula, but I have a square. So to get rid of a square, I have to take a square root. So the velocity is going to be the square root of 2L over A P V squared CL. All right, stop crying. I'm helping you walk through this. There's no crying in engineering, okay? So here we go. So this is what you should be putting in. So we have V equals, so we're going to have the square root. I'm going to make this nice and big so that you can see. 2 times L, which is going to be the answer for step 4, I do believe. Yes, step 4 answer. Then you're going to divide that by our wing area, which gave us back up in question 8, which is 427.8, okay, times our air density, which should be in our question that we had. Oh, this is step 1, okay? So this is answer for step 1, okay? Times our coefficient of lift, which they gave us, which was 1.24. Is that correct? Oops, I don't know why I had that. That should not have been there. That's my bad. Confusing. All right, so there we go. I messed up with that. Sorry, that's V. Okay? So plug these in. This is what your equation should look like. Okay? All right? We're not done yet because now I'm about to blow your mind. Okay? So now this velocity is going to be in meters per second, but that isn't what's on the gauge. What's on the gauge is kilometers per hour. So you're going to take this answer, okay? So now you're going to take your V and you're going to multiply it by 60 because there's 60 minutes in an hour. And then you're going to multiply that by 60 because there's 60 seconds in a minute. So we have to go back into our conversion. So we get into per hour. Okay. And then we're going to divide that by 1,000 because we have meters per kilometer. Okay. So there you go. That's what we have. Okay. So again, just to review this real fast, here's your equation. Sorry I messed this up. I don't know why I left that in there. You're going to take the square root of 2 times your answer for step 4 divided by your 4.278, which is the area of your wing, times your answer to step 1, times your coefficient of lift, which is 1.24. That's going to give your velocity in meters per second. So then you're going to take this answer and you're going to multiply your answer by 60, then by 60 again, and divide it by 1,000. And that will give you your number in kilometers per hour. Yay! All right. Finished.